Hello everyone. Today in this video we'll be covering the chapter of properties of ionic compounds. Now this is sort of the same as we studied them in O levels, so it won't be that much of a surprise, but do follow through. Now we already know that ionic compounds have a structure as that of a lattice when they are in their solid state. Now in a lattice it is that a negatively charged ion is always surrounded by a positively charged ion, and that is what enables the force of attraction between them to be in such a regular arranged lattice. Now this giant ionic lattice is one in which each positively charged ion is surrounded by six negatively charged ions. Now in this structure, in this semi structure that I have drawn of a lattice, in that you can see that this sodium ion, which is positive, is surrounded by three chloride ions, right? Now, if this extends towards these sides, right, you will see that there are three more chloride ions that can be surrounding it. So overall, the fact remains that six negatively charged ions are surrounding one positively charged ion. This stands true for a chloride ion being surrounded by sodium ions also. And so this is one thing to remember, because often MCQs do come expecting you to know how many ions would be surrounding one ion. So do keep this fact in mind. This is actually a very important figure. Now, beyond the lattice structure, you should know that whatever properties we study of ionic compounds, all of them, or most of them at least, will be in terms of the lattice structure. Okay, now the first property that we'll be studying is the high melting and boiling point. Now, ionic compounds have high melting and boiling points because of the force of attraction between the oppositely charged ions. These forces of attractions are so strong that they need an extreme amount of energy to be broken. These ionic bonds need a lot of energy to be broken, and so that is why there is a very high melting point. Now, why is there a very high boiling point? Now, there is a very high boiling point because, and the boiling point is always higher than the melting point in ionic compounds cases, because in a boiling point, to reach the boiling point, to surpass it, you need to break all the bonds. So in melting points where you need to overcome the forces of attraction simply, in boiling points you need to overcome the ionic bonds also, and that requires a lot of energy. So melting point and boiling point is always very high for ionic compounds. Now the second property that we'll be studying is the strength or brittleness of ionic compounds. Now we already noticed that a positively charged ion is surrounded by negatively charged ions, and so vice versa. So this is the simplified diagram that I can draw. Now imagine that this is pushed, a force is applied in the horizontal plane. That would enable that the structure is distorted. Now a positively charged ion would be surrounded by a positively charged ion, and a negatively charged ion would be surrounded by a negatively charged ion. That would lead to repulsion, and instantly this would break. Now that would lead to the strength and brittleness of ionic compounds being very easily shattered. So ionic compounds can be easily shattered. Keep that in mind, because they can be easily distorted. The next property that we'll be studying is that of electrical conductivity. Now, two things we learned in O levels: that ionic compounds do not conduct electricity in its solid state because they do not have any delocalized electrons or free ions moving around. Now, in liquid or aqueous states, however, the lattice structure is broken and we do have freely moving ions, and that leads to electrical conductivity to be quite possible. Now, that is all that you need to know about electrical conductivity. Do keep in mind. Now, the next property that we'll be studying is solubility. Now, don't be too wary of the diagram that I have drawn. It may look very confusing, but it'll become quite simple. Now, solubility of ionic compounds that we normally relate to is that in water, because we know that ionic compounds are, most of them at least, are quite soluble in polar solvents. For example, water being one of the most common polar solvents that we use. Now, suppose the example of NaCl, a very common ionic compound, which we use literally on a day-to-day basis. Now, we know that water has molecules of H2O in them. Now, the sodium ion is a positive ion, and so the delta negatively charged oxygens of the water molecules will be attracted towards it. You can see that is what is happening over here. The oxygens are attracted towards the sodium, and for chlorine, the delta positive hydrogens are attracted towards it. This delta positive, delta negative labeling and the lone pair labeling that I've done is all because of the difference in electronegativity between oxygen and hydrogen. And this is a topic long discussed ago. Okay? So now we already know that we can see that the oxygen is facing the sodium and the hydrogen is facing the chlorine. This simply shows you the ion dipole attractions. Because of this ion dipole attraction, solubility occurs, and therefore ionic compounds are deemed soluble in organic in polar solvents. Now, for electrical conductance, there is an extension knowledge that is provided relating to the process of electrolysis. Now, in O levels, electrolysis was a very determining chapter, but in AS, it is not a part of the syllabus. So, this knowledge that I am giving, it is not for your AS syllabus, rather, it will help you in A2. So we know that electrolytes are liquids, or they are chemical substances that provide passage of electricity being there through ionic compounds. Now, electricity or electrical conductivity or electrical conductance increases. The capacity of it conducting electricity increases if the concentration of the electrolyte, an electrolyte is an ionic compound which is in liquid or aqueous state. Now, an electrolyte's concentration increasing will also increase the conductance. Why would it increase the conductance? Because the number of ions present are now more to carry the charge. So for example, if I have 1 mole per dm cube of NaCl solution, and if I have 2 mole per dm cube NaCl solution, obviously I have increased the concentration. If I have increased the concentration, then that means that the electrical conductivity will also be stronger. It will be higher because there are more ions present to conduct electricity now. So one thing to know is that if an electrolyte containing ions with a higher charge will conduct better than an electrolyte containing lower charge. For example, if we have an ionic compound that contains aluminium ions, and if we have and this is an electrolyte, and if we have an ionic compound that contains sodium ions, this will obviously be a stronger electrolyte. Why? Because it has more ions, or it has a higher charge, as long as their concentration is the same. So this is an extension knowledge, and that is it for this chapter. Thank you.